So I'm going to do a quick survey before I get going. How many of the people in the room are GCP users who are new to Kafka? Well, I'd say about 10%. Ricardo?
All right, so let's make a simple question. How many of you have heard about it or actually using Kafka somehow? That is great.
Wow.
Beautiful.
Okay.
You're in the right place. All right, so cool.
Last session of the day. All the Kafka enthusiasts are here.
Yep.
Awesome, cool. So this is a demo-heavy session. Hopefully that's good. But before we get into the demos, we want to do a little bit of context setting. First thing I want to talk about is where all of this, Kafka, GCP stuff fits in into a kind of a prototypical architecture. I'm sure you've seen this kind of a stream analytics architecture before. Another thing I want to mention actually before I dive into this is not a session on stream analytics per se. Obviously, because it's Kafka, we're going to talk about stream analytics quite a bit. There is another session for those of you who have missed it. It's DA 311. It's stream analytics or advanced stream analytics on GCP. Strongly encourage you to watch that recording if you haven't, attended that session. There's another session, DA 304. I believe that was on Tuesday, and that's also about stream analytics in real life. It talks about PubSub, not Kafka focused. So definitely recommend you watching the recordings of both of those sessions. With that said, let's get into this architecture here. So obviously there's ingest, right? We're talking about streaming analytics. We have to ingest data somehow. The Kafka people know about Kafka. For people who are new to GCP, there's something called Cloud PubSub. It's a similar service to Kafka. There are some significant differences, but in a lot of ways, it's optimized for doing stream analytics. And then when you need to process your streaming messages, you have a number of options as well. In the Kafka universe, there's KSQL, Kafka streams, and a bunch of others that Ricardo's going to do demos on. In the GCP world, the thing that we're going to focus on in this session is Apache Beam with Cloud Dataflow. How many people have heard about Beam and or Dataflow? Wow, more people than have heard of GCP. That's good. And then once you've done these transformations or processed this data, you can then write that to a variety of so-called sinks. You can write it to a data warehouse like BigQuery on GCP. You can do real-time predictions with Cloud Machine Learning Engine, or you could write it to a time series database like Cloud Bigtable. I want to look at this diagram through a slightly different lens. The main thing I want to call out here, we've talked about ingest and processing. There's also an important piece when we talk about stream processing, and that is this idea of connectors. Stream processing would be a lot more challenging if you had to write custom code to do, to pull data from all the sources that you need to read from, like MySQL, Postgres, GCS, et cetera. And then on the other side, if you had to write custom code to sync data into all these things. So out of the box, with Kafka Connect, you get a variety of these connectors in the Kafka world. On the GCP side, there are these Apache Beam I/O connectors as well. Between the Google-provided connectors and the community-provided connectors, you typically shouldn't have to write your own sources and sinks. This makes your job a whole lot easier, and we're going to be using one of those connectors in our demo today. I'll also quickly mention that you can use the Hadoop ecosystem of both processing tools and connectors, with Cloud Dataproc. This is our managed Hadoop service on GCP. We're not going to be spending a lot of time talking about that today, though. Even though there are quite a few people that know about Beam, I want to spend a little bit of time kind of level setting on what Beam is and what Dataflow is. So Beam is, or Apache Beam, I should say, is essentially an open source SDK that lets you write code in Python, Java. Now we have Go support, and we also now have SQL support, which is really awesome because when you can do SQL against streaming data, it makes it a whole lot simpler to kind of reason about it and actually focus on your application logic. And then Beam has a variety of runners that you can actually run your Beam code against. One of those runners is Cloud Dataflow, which is native to GCP. But you don't have to limit yourself to that runner. You can also use Apache Flink, Spark, IBM Streams, etc. So that's kind of the key distinction, I guess, or the thing to keep in mind between Beam and Dataflow. I sometimes use these two terms interchangeably, but just keep in mind that Dataflow is the runner and Beam is the programming model. All right, now I'm going to hand it over to Ricardo to get into Confluent Cloud.
All right, thanks, Karthi. I'm going to spend a little bit of time explaining what Confluent Cloud is. We're going to have a lot of, I think, a series of 3 demos, right?
Right.
Confluent Cloud.
Right. Lots of demos.
And yeah, the talk part is going to be only this part. I mean, after this, we're going to go straight to the code, and it's going to be fun. Confluent Cloud is actually the result of the combination of Apache Kafka, and we've actually released this service a couple years ago. And the primary objective of this service is to make available Kafka as a managed service. So in other words, you don't have to, as a developer, as administrator, to manage, install, patch, upgrade by yourself, and you use it as a service in whatever cloud provider you want to choose, whether if it's GCP, AWS, or Azure, right? Some of you might have heard this week that we straightened our partnership with Google Cloud. And as a result of this, we are bringing Confluent Cloud as a first-class citizen for GCP. What that means for you is you're going to be able to spin up Kafka clusters straight from GCP console or GCP CLI, G-Cloud, right? As well as instead of having 2 subscriptions and 2 billing modules, you're going to have to use your own credits from GCP and spin up your clusters, and that's it. You don't have to pay extra money for Confluent and all of that, right? By the way, how many of you know what Confluent is? You make me very happy by raising your hand, sir. Thank you. All right, so Confluent, for some of you that don't know what Confluent is, it's a company that was founded by the original creators of Kafka. So long story short, Kafka has been created on LinkedIn plus 10 years ago, and the original creators kind of left LinkedIn and built their own company. They call it Confluent, right? And we've been spending a lot of time kind of managing Kafka at scale for the last 5 years. And Confluent Cloud is the result of this expertise that we built in Confluent. I mean, we became pretty good at managing Kafka at scale, so we created this service for you, so you as a developer don't have to worry about how to install Kafka. I mean, if you think about it, Kafka has been around for what? Plus 10 years, right? It's been created 2007, I think, and open sources to Apache in 2008. So it's definitely not a new technology. So why don't you have to worry about the cluster itself? What you have to worry about as a developer is building applications and connect to clusters, right? Just like you would do with a database, right? Redis or SQL databases, NoSQL databases, etc. Right? All right. So on top of a managed Kafka service, what also Confluent provides is a set of resources and technologies and built-in implementations that we've been developing for the last 5 years, and that's the value that we also get with Confluent Cloud. So if you are a Kafka developer, you know that for implementing an end-to-end stream process data analytics, you have to use a lot of other implementations. Sometimes you have to sit down and write the code yourself, whether it is for connectors, whether it is for your consumers, whether it is for managing Kafka properly. So as part of the Confluent Cloud subscription, you also get access to a bunch of other stuff that makes Confluent Cloud not only another managed Kafka service, but also actually an end-to-end complete solution for building stream analytics on top of Apache Kafka. So 3 main examples: clients. Whether if you are developing Java, C++, Python, Node.js, or Go, we have native clients for you, right? And actually, those are clients that are supported by Confluent, so you can actually raise tickets for support. Connectors. We have a bunch of connectors that we kind of productize it, and if you want to have, for example, native connectivity with BigQuery, there's a connector for this, right? If you want to store data on Google Cloud Storage, there is a connector for this. So all of that makes you, as a developer, shorten the time you would have been spending creating and implement your projects. So that minimizes your risk, your technical debt, right? And lastly, we also provide a lot of cool things like KSQL to do string processing, and I'm going to be demoing this in a moment. You're going to get to see how KSQL works, how it looks like. For those of you that never heard about KSQL, I am confident that you're going to like it, right? Especially if you are a developer that has been developing Kafka streams. How many of you have heard about Kafka streams, the Java or Scala library? So Kafka streams is a way to implement string processing in Kafka, but KSQL is a much easier way to implement that. So that's part of our subscription as well. As well as we have a lot of Docker containers, Helm charts if you want to deploy Kafka on top of Kubernetes. And of course, we have Terraform scripts to spin up VMs with all these things and whatever cloud provider you wanted. So that's the value that comes with Confluent Cloud. It's not just managed Kafka service. So I would like for you guys to keep that in mind. Besides this, it is very easy to work with Confluent Cloud. And I'm going to be showing right now how that works. So I know that some of you might be thinking, OK, all right, talk's cheap, right? Show me the code. And I'm going to spend the next 3 minutes. And within these 3 minutes, I'm going to create a cluster in Confluent Cloud. I'm going to create a topic on that cluster. And I'm going to create producers and consumers to read data and write data to the topic. Then hopefully, I will be able to do this in 3 minutes. So, all right, let's do it.
You switch to the demo machine, please. Thank you.
Good point. All right. So let me put this aside. And I am in my workspace here? Yeah.
Yeah, that's you.
All right, so that's me. So what I'm going to do now is log in into Confluent Cloud with my account that I've created before. So I'm going to be providing the link later so every one of you can sign up for Confluent Cloud and spin up your clusters. I think we are in the wrong window, right? Because maybe the wrong browser.
Let's do this.
Yeah.
The joy of sessions and sharing login.
The beauty of doing demos alive is that the audience gets some fun as well.
Don't tell anyone that we're using Safari.
Exactly. But it only was in Safari. So where you're looking right now, it's we have this concept of environments. So when you are creating your clusters, you want to separate them in dev, prod, QA, or you maybe want to separate them by lab, right, line of the business. So I have an environment here that I created for myself. And within an environment, you can create not only clusters, but also schema hash history, which is another component that's very useful when you're developing Kafka applications. Schema hash history, long story short, is where you can store your schemas. And currently, we are providing support for JSON, protobuffers, and Avro. So wherever you want to serialize your records using one of those technologies, it is supported by schema hash history. And more importantly, it's part of your subscription. So it's a managed schema hash history server that you don't need to set up by yourself, which is pretty cool, right? So let's go back to the cluster tab, and I'm going to create a new cluster. And I'm going to call this cluster, for obvious reasons, I'm going to call Google. Too many O's. Google Cloud Next 19, right? And it's interesting because we made it very easy for people to size clusters. So basically, we ask 4 questions for you. What's going to be your write throughput in megabytes per second? What's going to be your read throughput in megabytes per second? What's going to be your storage necessary for that cluster? Because as you know, Kafka is persistent. All the records that's flowing in through Kafka end up in the disk. That's why we need storage. All right? And in the end of the day, you also get to choose which cloud provider. Sorry. How do I scroll down? Right here. This window probably can. OK, good. You also get to choose which cloud provider, which I think is a good idea to choose Google for this time, right? What do you guys think? I don't know. Maybe. Once you choose the cloud provider, you also get to choose what region you're going to work with. And if you want to have high availability, you can also choose which availability zones you want your clusters to be replicated. So we're going to spin up brokers on that regions. And if you want high availability, you would have 3 instances of a broker per availability zone. And they will keep in sync for you for in the event of you have full tolerance, extra full tolerance. So, and you might have seen this, that by the time you all do this, all these options, you see right away what's going to pay for it. So it's going to cost 0.54 cents per hour, which is very good if you're doing a POC. So you can simply spin up your cluster, do what you need to do, and then after that, you delete the cluster. It's pretty cool, right? So let's launch a cluster. Believe it or not, the cluster is running, right? So this is the Bootstrap server endpoint that is publicly available, which I'm going to use to set up my CLI to communicate with the cluster. But before that, one thing that you need to do is to create your own set of client credentials, because you need to authenticate yourself to the cluster to say, OK, I am authorized to communicate and produce and consume records from that topic, right? So 3 informations: Bootstrap servers, API key, API secret. So what I'm going to do, I have this guy over here, and I have the CLI from Confluent Cloud installed on this computer. We call it CC Cloud. And the first thing you do is to init. So it's going to ask, OK, all right, I got it. What is the Bootstrap server? So here is the Bootstrap server. OK, so what's the API key? That's the API key. Common V. And what is the API secret, which at this time, I don't think is a secret anymore, right? For obvious reasons. So I'm going to pass it here, right? And I'm going to put this aside. And there you have it. So we now have our CLI hooked up with our cluster. So if you type cCloud topic list, there will be no topics for obvious reasons. This is a recently created. Let's create a topic for fun. CC Cloud topic create. I'm going to call it test. And I'm going to keep things default here, but I could have specified the number of partitions for the topic, the replication factor, and all that stuff. All right? So if you go back to our console and look through the topics option, here's our topic. So what I'm going to do now is to inspect that topic right here, and there's an option called inspect that monitors in real time all the records that are flowing through the topic, right? So this is our consumer in the end of the day, and what I'm going to do here is to produce some records. Produce minus T, where's the topic name? Test? Yeah, test. So I'm going to produce the famous that every developer loves to use as a test. Hello world, word with L, right? Hi, Karthi, sup. And if we go back to our console, here's the records. So
very cool.
That's a producer, a consumer, ready and writing data to a topic. We create a cluster from scratch, and I don't know. It has been 3 minutes. Yeah. Less than this, hopefully. All right. So that, guys, what I would like to demonstrate here is, as a developer, you don't want to spend time managing Kafka by yourself. Kafka is a proven technology, the brokers, the cluster itself. What you want to spend time is to developing code to communicate with Kafka. Right? So that's the value that Google Cloud is bringing to you as a service. All right? With that said, I'm going to hand back to my friend Karthi, and we're going to carry on the presentation.
Thank you. Can we switch back to the slides? Thanks. So before I get into my demo, I want to spend a little bit of time setting up the context here for the demo. You saw how easy it is to stand up a cluster. When I did this session last year, I had to stand up my own Kafka cluster. It was not fun. This is so much easier. Yeah. Now we can get into how we actually do processing, right? So here I've cooked up a kind of a contrived scenario meant to highlight the goodness you get when you bring together Kafka and GCP. So one thing that I see a lot when I talk to customers is they've had a number of applications that they've been building over the years that they've deployed on-prem. Now they want to take advantage of GCP. These may be applications that use OLTP databases that generate a lot of data that would be interesting to analyze. So when they go to GCP, they'll deploy new applications that are cloud native, that are also generating their own potential analytics data. Analytics doesn't care where the data comes from. You just want to be able to analyze over all of your applications and see what kind of trends emerge, et cetera. And one possible way to approach this when you're doing streaming analytics is use the power of Dataflow and the ability that Dataflow has to pull data from different sources to then generate analytics, cross-cutting analytics across applications. So what we're going to do here is we have the on-prem application sending data to Kafka that's in GCP, like Ricardo just showed you. Ricardo's actually going to go into more details on how you can set up Kafka Connect, as illustrated on the top left there. We won't talk about that right now. We're going to assume it's, well, not assume, I've actually set up a Confluent Cloud Enterprise Kafka cluster already that I'm sending data to. And then I have a pub sub topic that I'm sending data to as well. And with Dataflow, I'm going to combine those two streams, merge them, and then write it to BigQuery, which is our serverless data warehouse. And then we can do some queries against that data that's in BigQuery. So that's the goal. Before I switch to the demo, one other thing I wanted to mention is I have this rather unglamorous application. I'll let Ricardo do the cool demos. This is essentially a loan processing application that takes requests coming for loans and decides whether to approve them or reject them. And the only field of interest here is the credit score of that user. As you'll see in the code that I'm about to show, we'll look at the score and say, hey, if the score is below 700, then we're going to reject the user. If it's above 700, we'll approve the user. All right, now let's switch to the demo machine, please. Awesome. Yeah, I'm actually going to jump to the code right now. Actually, before I jump to the code, let me actually mention one other thing. How many Java developers in the room? How many people have actually used Java? OK, quite a few. Awesome. And the reason I ask is there are a number of built-in I/O transforms that Apache Beam, the thing we're going to use to do this processing, unified processing. Beam, for Java, has a Kafka I/O connector. In the Python world, the Python I/O connector is still being worked on. It's not available yet. In addition, for those of you who attended the new, DA 311, the new announcement that we made about Dataflow SQL, you could use Dataflow SQL with Kafka. It's an experimental stage right now. That's actually why I'm not going to demo it. I'm not brave enough to do that. But strongly encourage you to play with it. You can do some of the things that I'm showing you now. As soon as this matures, you can do it in SQL in the same way that Ricardo's about to show you how to do in KSQL. So SQL makes life a whole lot easier for a lot of analytics. With that said, let me jump into the Java code here. I've actually got this deployed already, but I want to talk through a couple of important aspects. So this is my main class, once again, not creatively named. Essentially, I'm merging the pub sub and Kafka streams into one stream and then writing that to BigQuery. And the thing that I want to call attention to is I'm using the Kafka I/O Beam connector, and I'm specifying some of the key attributes that Ricardo showed you earlier that I pulled from my Confluent settings. Do all of that there and write everything or pull everything into something called a P collection. In Beam, this P collection is the thing that you do transforms against. You can do a lot of interesting things. In this case, all I'm doing is, before I write the data to a P collection, all I'm doing is checking to see if the credit score is above a certain threshold. If it is, then I let it pass through. Similarly, I'll do the reverse on the pub sub stream, read data from a pub sub subscription, decide if the credit score is below a certain threshold, and then let that through. And this is the code here, or the transform, I should say, for merging the two pipelines. You can see it's idiomatic Java. It's very easy to follow, except for all this stuff here. And then I turn around and write it to BigQuery. And when I do this write to BigQuery, I'm using something called a streaming API for BigQuery, which actually lets me do SQL against the data that's being written to BigQuery in near real time. And I'll demonstrate that real quick. And that's actually an interesting scenario because simply by virtue of writing this data into BigQuery, I can do SQL analytics. I'm just doing it in BigQuery, that's all. So I've got this table. It's called merged credit applications. And I'm going to query that table. I'm I'm just going to do a count for.
So just for you to know, while Karthi is typing the code, we have this producer running on a GCP VM that's continuously sending records to our pipes, and those records are being streamed using Dataflow, which in turn end up in BigQuery. That's what Karthi is going to query right now.
Right. Thank you. Yeah. So you see that it says 408. And when I run this query again, and this is happening in near real time, the count has gone up. So you can actually do more interesting queries against this data as it's being written into BigQuery. So it's a cool integration opportunity that you get when you bring Kafka into GCP. A couple of other points that I want to mention real quick. Customers have gotten are really excited about using Dataflow and Beam against Kafka. Two gotchas to remember, and that is on the networking side. When you deploy Kafka with Confluent, you get a peering relationship. This is for the enterprise edition, right, Ricardo?
Yep, that's correct.
Ricardo's going to cover that in more detail. When you write a consumer that consumes data from this Kafka cluster, you have to make sure that consumer is in the same VPC that is peered on your side. If you don't validate the connectivity, you'll run into a lot of issues on the Dataflow side. So a couple of suggestions that I have to validate connectivity is once you have the name of the Kafka cluster, let me just grab this real quick. My mouse will cooperate. So that's the Kafka cluster that we've deployed. And what I'm going to do is essentially I'm going to log into a VM that's running in the peered VPC that I mentioned earlier. Once I've logged in, I recommend first telnetting against 9092. That's the port that Kafka gave me. And you can see that I was able to connect. So that's one. And another suggestion that I have is actually trying to validate that you can use the Kafka consumer. And I'm actually not going to run it right now because I think we're running short on time. But as opposed to the C-Cloud approach, I would recommend just using the Kafka consumer that comes with the distribution and validate that you can talk to the topic. Now, the last piece of or the last takeaway from this when you run Dataflow against Kafka is, since we're talking about Java, you're going to use Maven. You're going to specify the network that your Dataflow job runs from. This is very important. If you don't do this, Dataflow is going to kick off in the default network, and that may not be the peered network that you set up. You can also specify the subnet. So the networking aspects of this are important to keep in mind, in addition to obviously specifying that you want the Dataflow runner. When you kick this off, for people who are familiar with Dataflow, if you kick it off from your local machine, which is what you may do with a lot of Dataflow jobs, the local machine cannot see the Kafka cluster usually because there's no path to the Kafka cluster. And this is the error you'll get. It'll say timeout expired while attempting to fetch topic metadata. And the way to ensure this doesn't happen is, once again, create a VM like we did here, the same VM that you maybe attempted to telnet from, and kick off your Dataflow job from here. So keep all of that in mind, and hopefully you'll have fun playing with Dataflow and Kafka. So with that said, I'm going to hand it back to Ricardo. Back to the slides, right?
Yep. Back to the slide. Thank you. Thank you, Karthi. What I'm going to do now, it's a two-steps process of showing you how to do KSQL processing, exactly doing the same thing that Karthi did with Dataflow and Apache Beam, sending data to BigQuery. But in this case, what we're going to do actually is do string processing and then sending data to a Google function using Kafka Connect and KSQL. But why I said is the two parts, because I want to set the stage first so you have a better idea about how KSQL works. So we're going to do a quick demo about KSQL itself. And after we run into the demo, I'm going to show you the other demo, which is actually doing exactly what Karthi did, but using KSQL and Kafka Connect. All right? But first, let's talk a little bit about KSQL. And the way I would like to showcase this is to using mobile phones for producing records that are going to be process using KSQL, right? So in order to demonstrate how we're going to do this, I'm going to do this with my friend Karthi first. And then once you see how this works, you guys are going to get to produce the events using your mobile phones, which I think is going to be real fun. So where is the terminal? All right. So what I have here is a KSQL client installed on Karthi's computer, and I have a KSQL server running on GCP. KSQL server is where you deploy your KSQL queries, right? Simple as this, right? So in this KSQL server, I have, if we type the topics, you're going to see all the topics that we've created for this Kafka cluster. But we also have the concept of streams, which basically are abstractions on top of topics, right? If we describe the stream, which is basically describe the metadata about this particular stream, we're going to see that this stream actually is based on Avro. So that's the format for the records that I've been working on for this demo. And it has a complex data structure, like it has a name field and two child fields called motion and speed. And within those columns, let's say columns, we have child attributes. So that's one of the powers that KSQL brings to you, because you can actually handle data structures that are non-trivial, are not simply flat tables with columns, right? You can actually deal with complex data structures, complex objects coming from whatever you're serializing, like protobufers, Avro, or JSON. So what I'm going to do now is, Karthi, you have the application running?
I actually don't. What was the URL again?
All right, let me type it for you. No worries.
Thank you.
So we have this URL running. He's going to start moving his phone with his hands, of course, right? I'm going to execute the square right here. And what you should see here is all the events coming from his phone. He's going to type his name, and all his gestures and movements from the phone are going to be populated the variables x, y, and z.
Working.
Here you go. So that
was harder than it needed to be, but it is working, yes.
Yep. So let's try this, Karthi. If you close your browser now, let's see what happens with the KSQL console. So the event stops because it's actually real time.
Just don't ask me to bring up the app again, because that was hard.
You forgot the URL. I know it. Yeah, I got it. So let's do this. I'm going to left the query running with one small change. So I'm going to interrupt this query. And you saw that I've selected everything first, right? So let's do this. I'm going to basically show the name, the field motion, but with the attribute x as x, the field motion and the attribute y as y. As y is kind of a weird, right? And motion and z as z. So I'm going to make things simpler. And my friends in the back, could you switch back to the slides, please? And what I want you to do is to grab your cameras from your phones, scan that barcode over there. It's going to pop up a URL where you're going to see the application, right? Type your name or nickname or whatever you want to be called.
Something nice.
Something nice. Don't be rude.
Because it's going to show up.
It's going to show up here. And then when you click play, you're going to see a cube that moves with your hands, right? A quick disclaimer for some of you that uses iPhone, specifically with iOS 12.2. It's not going to work. Not our fault, Apple's fault, right? If you are an Apple user, go to our Safari settings, right? Settings, Safari. There will be this toggle right there. Now they make it optional to use for any application to access the accelerometer of your API. So now you have to check it explicitly in order to work. If you do that, that's a workaround, and then you can come back to the application. It's going to work. My friends, now you can switch back to the demo. So yeah, we have a couple names popping up right there, test. For those of you that uses Android, it's going to work right off the bat. So
we're going to rerun it, see what happens.
Well, it should be popping up some events right now, but let's see. Probably
I swear it was
stuck.
working, but only I could see it.
Yep.
Because he told me to switch it back to the slide.
Yeah. Probably it's kind of going through the satellite, going back to Earth, and then the internet connection is kind of an
But you get the idea.
Yeah, you got the idea. That's at least we have.
There's
your
a
name.
proxy involved that we did not necessarily beef up before it gets to Kafka. So, yeah. But anyway, you get the idea. It gets
Yep.
to Kafka.
Exactly. So let me stop this. Everybody got the cube moving with the iPhone? Well, at least one thing you learn with this presentation, like how to enable the cube in your phone. So that's cool. Right, so presentation, please. All right. So that said, let's actually take a look. And I'm going to go back to what Karthi did originally. And I'm going to show you how that will be the implementation. Now that you learn how KSQL kind of looks like, it's a query, right? KSQL is simply an abstraction that we created on top of Kafka streams, right? So we have the concept of KSQL servers that you spin up wherever you want, Docker, Kubernetes, Naver, bare metal, whatever you want, and you deploy queries. We are in perfect sync about. All right, so it's Safari or Chrome?
That's Chrome. Yeah.
All right, Chrome. We have this guy called Control Center that is a monitoring tool that comes with Confluent Cloud. It's free to use for wherever has the subscription for Confluent Cloud. And as you can see here, we have this topic that Karthi was using before that was getting all these events from this producer that is running somewhere, right? So that topic is continuously receiving all these credit applications. And we have this field called credit score right here. So what I did in this implementation was effectively using a couple of streams on this deployment. So the first stream I created was what we called wrappers. Wrappers is a way, as the name implies, I mean, you have to come up with a representation of your Kafka topic to KSQL. So the best practice is always create a first wrapper. So it's going to be your, like if you are in ETL processing, that's going to be your first data stage, right? That's the wrapper. After this, I created a streams that you can basically describe all the fields right here. And actually, there's a better way to describe this, which is running a query right off from Control Center. So I'm going to describe, sorry, extended, applications. I think I put in plural, stream. And I'm going to run it. If you do that, you have access to the actual sentence about how do I create this. So KSQL language, create stream applications, approve it with, we can change the format interchangeably between JSON, Avro, protobuffer, CSV. So that's one of the beauties of KSQL as well. And as you can see here, I'm basically querying the applications wrapper, right? So how do I minimize a little bit so we can see everything? OK, good.
Like that?
Yes, yes. And probably make it worth for you to read everything, but I want to show you the where condition clause over here. But what's interesting about this is not only the wrapper, but this query right here that I call it applications rejected, right? So applications rejected is, let me...
Big question, is that really small in the back?
Yeah.
I think we should make it a little bigger.
Bigger, right?
Yeah.
Let me just run this, and you can increase the font. All right, go ahead.
Fortunately, when we connect it to the monitors, it reduces the resolution.
Yeah. So let me scroll down a little bit so you can see the results of this query. So I created a stream called rejected alert that basically queries the previous streams. So not sure if you're getting the feeling here, but when you are creating streams, you are creating a chain of processing. A stream that produces results that can be queried by another streams that produces results, just like ETL pipeline, right? But in this case here, we're actually querying a applications rejected stream, and we're creating a window tumbling. That's pretty cool, because within that result, we can specify a window of 1 minute, 1 hour, 1 day, 1 week. And all the query are going to be applied to that window. And we call it tumbling because that windows keep moving all the time and always generating new outputs and new records, right? The output of this, right? Every time you create a stream rejected alert, for example, in the end of the day, you are also creating a new topic. So the name matches rejected alert. So if you query this guy, you're going to see all the records that are coming in. It's been filtered already, right? And I am pretty sure that since they have been rejected, the credit score is going to be always less than 700. Because that's the where clause that we created, where credit score is less than 700. So we filter the stream and produce it an output that is being sent to this topic, right? All right, so we produced the records, we did the string processing, and what you can do with it, what useful thing you can do with it? You can use Kafka Connect, where you can set up sources and sinks. In this case, I'm creating a sink, right? So I'm syncing into something. I'm willing to grab all the records from that topic and send somewhere else. What I'm doing here for this connector specifically, let me show you the details of it. You see that I'm reading from the topics rejected alert. So this stream is being, the result of this stream is being sent to this HTTP endpoint, which happens to be a Google function. So what we are doing here is actually grabbing the result of the string processing and calling a Google function using HTTP as the technology enablement for sending the results to it. So Karthi can show you the dashboard where you can see all the Google functions being called and the throughput of it. So
everybody know what Cloud Functions are? Essentially, it's our serverless.
Oh, yeah, that's
essentially
good question.
Way of running code. It's been around for a little while,
yep.
And I wrote a Cloud Function that took me many days to create, which is why it looks this simple. It's called Hello HTTP, and
yeah,
it has
very creative.
All it has is essentially some code that prints out the payload that you pass into it. But the key here is you can see that, you know, what Ricardo did, which, by the way, the highlight there is it is a little bit different from analytics, right? When you're doing analytics, you can use Dataflow or KSQL or Kafka streams. Yep. But here, you're trying to take some action. As a company that may be processing credit card applications, you want to see if you're getting more rejections than you're comfortable with, you know, over a window. In this case, the tumbling window was 1 minute. Yep. If you do, then you want to take some action. You can do that by calling this Cloud Function using KSQL and Kafka Connect. This Cloud Function could send an email. I could have set it up, but I didn't want to show you my inbox. But you can do the rest. You can use one of many suppliers like SendGrid to generate an email or call into ServiceNow or something like that. So the integration is pretty cool.
Cool.
Back to slides?
Yes, please. All right. So we've seen how this works. Let's talk a little bit about some best practices about how to use Kafka with Confluent Cloud effectively with GCP, right? So there are two biggest scenarios that we usually talk to customers when they are planning to do Kafka implementations on top of GCP. The first one, we call it hybrid cloud. How do we call it hybrid cloud? Because you already have a lot of Kafka cluster running somewhere in your data center on-prem, maybe your own servers or some co-located data center that you hired to host your applications. And your plan is eventually get into GCP, right? So what is the plan here? The first step is actually create a Confluent Cloud cluster, right? And you saw that it's pretty easy to spin up one. And there is a technology called Confluent Replicator that comes with Confluent Cloud that you can use it as part of your subscription. It's there for use it. You don't have to buy anything else. For those of you that come from Kafka background, is built on top of Apache Mirror Maker, right? Essentially, it's Apache Mirror Maker, but with some enhancements to ensure reliability to deliver of the records when they are replicating. For example, if you are relying on if you are using some non-reliable links to connect your data center to Confluent Cloud, you might have network hiccups, or you might have network outages, right? So what Confluent Replicator does is ensuring that data that is in motion will be reliably delivered. even though you have outages, even though you have hiccups, right? So it's ensure ordering, it ensures consistency. So the plan is move all the data to Confluent Cloud. So it's as long as all the producers and consumers are reading and writing data to your data center customers, data center applications, that data will be moving up to cloud. And eventually, when all the data is there, you can simply bring your producer and consumers to GCP, wherever you want to host it, Docker containers, Kubernetes, bare metal, you choose, and then you repoint your consumers and producers to Confluent Cloud Cluster. So that's basically the plan when you are moving workloads from on-prem to Confluent Cloud, to GCP, sorry. The nirvana for everybody that's working with this technology is to do cloud native. What is cloud native? Is when your Kafka cluster kind of born in GCP. Why is it nirvana? Because you don't have to do this whole migration process, right? And when you do that, Karthi kind of touched base a little bit and a couple minutes ago about how do we do this communication between the Kafka cluster and the producer application. So long story short, we're probably running out of time in a couple minutes, but long story short, what you have to do is, once you provision the cluster within GCP, your applications, producers and consumers will be running in your own VPCs, right? That's the best practice because you want to isolate your workloads. You should be able to treat your Kafka cluster just like you treat a database. It should be running on your own VPC, private subnets, not publicly available, and it's protected, right? So what you do is to request a VPC peering. So what we're going to do is ask two questions. First one, what is your project ID from GCP? Second question, what is going to be your network ID? With these two informations, we can do the peering for you. That's what we did for this demo. So we have a Confluent Cloud Cluster running on GCP, and Karthi, it's kind of running its VM on its own project that we peered with the Confluent Cloud Cluster, right? So that's the plan for having this communication. You don't want to have your Kafka cluster publicly available for security reasons, right? That's not good, all right? Lastly, Confluent is available everywhere. I mean, the plan, of course, is to have Confluent Cloud running natively as a first-class citizen on GCP. That's what we recommend as a best practices. If for some reason, maybe a personal desire, maybe it's a regulation that you have to comply to, you need to have Kafka running on your own data center within your constraints, you can always download the bits and install by yourself, right? That's what we call co-located data center. You can actually have your data center hooked up by network features of GCP, and you can have this communication back and forth from GCP to your data center. Or, better yet, if you want, for some reason, use another cloud provider, such as, I don't know, AWS or Azure, you can also have Confluent running there, and you can use Confluent Replicator to sync up all the data between the regions or different cloud providers. So the most important thing here is that we provide options. That's the beauty of the partnership that Confluent did with Google Cloud. Provides you, as a developer, the options for doing that. That said, guys, I highly encourage you, if you scan that barcode, it's not going to be the game again. It's basically, use that barcode for sign up for Confluent Cloud if you want it. You saw it in the beginning. It's very simple to create a cluster and start using Apache Kafka. There are going to be some videos on that link as well that show you everything that we show it here. And be fun. I mean, stop the struggling. Come using it as a service. Right? That's the recommendation we have for you.
Oh, thank you. And thanks for coming. Please submit feedback. We would really appreciate it. Yeah, thanks again for attending the very last session.